Everybody, in this class we are going to study about equation of refraction of light. In curved surfaces. From the derivation we got that N2 by V minus N1 by U is equal to N2 minus N1 by R, where N1 is called refractive index of first medium, N2 is called refractive index of second medium, V is called image distance, U is called object distance, and R is called radius of curvature. What do you mean by radius of curvature? Radius of curvature is nothing but the distance between center of curvature and the curved surface. The distance between the center of curvature and curved surface is called radius of curvature. You might be asking a question regarding what is the equation of refraction of light at plane surfaces. When we consider plane surfaces, the radius of curvature will be tending towards radius of curvature tends towards infinity. When radius of curvature tends towards infinity, the above equation becomes N2 by V minus N1 by U is equal to N2 minus N1 by R initially, but R is replaced by infinity. We know from simple mathematical calculation that anything by infinity is equal to 0. Then N2 by V minus N1 by U equals to 0. Then N2 by V is equal to N1 by U. This is the equation for refraction of light at plane surfaces. And let us study about focal length. Up to now, we confined our study by considering a curved surface. We are going to study in this class by considering convex lens. The midpoint of this lens is called optic center. The midpoint of this lens is called optic center. If you consider to be a sphere, then the center of the sphere is called center of curvature, and this is called focal point. I already told you. And here also we have one more focal point, and here also we have center of curvature. We join these lines, a line joining center of curvature and focal point is called principal axis. Let us consider this to be C2, F2, F1, C1. And remember, F is equal to C is equal to 2F. So C1 can be represented as 2F1, C2 can be represented as 2F2. And since we are considering a convex lens, let us consider if the light rays are traveling parallel towards principal axis, these light rays will be converging at one point. These light rays will be converging at one point. The converging of light rays at one point is called focal point. The converging of light rays at one point is called focal point. When the light rays that are drawn parallel to the principal axis and passing to the convex lens, they converge at one point, and the point of convergence is called focal point. Point of convergence is called focal point. This convex lens can also be represented like this. Draw the same diagram, draw the lines parallel to the convex lens, and as a result, this convex lens will be converging at one point, and the point of convergence is called focal point. This is F2, this is C2, and again this is C1, and again this is F1. So, if any light ray that is passing to if any light rays that are drawn parallel to the principal axis will pass to the convex lens, they will converge at one point. Hence, convex lens are called converging lens. Hence, convex lens are called converging lens. And after converging, they will just move. Let us study about concave lens. Concave lens are known as diverging lens. I already told you that concave lens are called diverging lens. These are thicker at the edges, thinner in the middle. These are thicker at the edges, thinner in the middle, and draw the lines parallel to the principal axis. When a parallel beam of light rays which are parallel to principal axis are passing to the convex mirror, they always diverge. They always diverge. They always diverge. They always diverge. Hence, concave lenses are called diverging lens. Hence, concave lenses are called diverging lens. Hence, it is very clear that concave lenses are called diverging lens. Concave lenses are called diverging lens. And they will be meeting at one point. The point is called focal point. This is called C2. This is called F2. This is called F1. And this is called C1. And convex lens can also be represented like this. I will consider a ray to show you very clearly. When a ray drawn parallel to the principal axis, when they are passing to the convex lens, they will diverge. And these diverging rays will be meet at one point, and this point is called focal point. Convex lenses are always known as diverging lenses. Convex lenses are always known as diverging lenses.